So on the bottom of page 1 here in section 9.4, need to fix these notes just a little bit. I copied and pasted the previous lessons instructions here in orange and then forgot to retype them to match this section, so I apologize. Let's fix that. The instructions should say, and let's use a red pen to kind of match that here. What you're going to do is rationalize each denominator. Rationalize each denominator and simplify if needed. So sometimes all you need to do is rationalize, sometimes you'll need to simplify. The book actually recommends that you rationalize first, simplify later. The method that I tend to fall back on is I try to simplify. Well, I do go ahead and rationalize, but sometimes it helps to simplify it first, and then you can rationalize using smaller numbers. So you'll find a way that makes the most sense to you, again, because of the fact that we're dealing with fractions, which is division, quotient rule, product rule, radicals, all this, it's all in the family. So there's lots of different ways you can go about doing this. It's kind of like dealing with exponents. You kind of got to do plenty of problems before you can kind of get your own style and rhythm about how to approach these. So let's look first at what rationalizing actually looks like. We're focused on the denominator, and if there's a radical here in the denominator, we want to multiply by that. And the reason why we want to multiply, in this case by radical 6, so why would we multiply by radical 6? Well, because when you do radical 6 times radical 6, what you get on the inside is radical 36, and we know the square root of that to be 6. Because you're just multiplying the 6 times 6. So remember, the goal here is to get rid of the radicals. We strategically we multiply by itself, the denominator, so that you can just end up with the whole number. Now, we can't just multiply the bottom, though. Okay, so we multiply the top by radical 6 as well. So multiply by the same thing, top and bottom. So that you're really just multiplying by 1. And multiplying by a value of 1, because when you have something that's the same top and bottom, it's really just like multiplying by 1. Multiplying by the whole thing here. So it doesn't change the value of the 4 over radical 6. This has the exact same value as it did before we tried to rationalize the denominator. But because of what we picked, it will allow us to recreate the denominator on the bottom. Because of the radical 6 times radical 6 gives you radical 36, which is just 6. Then the bottom becomes just plain old 6. Now the top is 4 radical 6. Now here's a situation where nothing could be simplified at the beginning, but after we rationalize the denominator by multiplying by what we see in the denominator, gives us our clue of what we're going to use. In this case, multiply by radical 6. We multiplied top and bottom by that, and what we ended up with is something that now can be simplified a little bit, because 4 is 2 times 2, 6 is 2 times 3, and so this is all multiplication on the top. 2 times radical 6. 6 is 2 times 3, and then one of those 2's is going to cancel, and so what we're left with is on the top 2 radical 6, and on the bottom 3, and that's your final finished version. Now let's look at number 20. What's different about this one? Well, in the first one, the radical was just on the bottom. The second one, the entire fraction is under the radical. So at first glance you might think, wait, there's no radical in the bottom here. If you remember back a couple sections, one of our finished, quote unquote, finished answers was like radical 3 over 7. What that really meant when we started to investigate like quotient rule and that kind of thing was that really meant radical 3 over radical 7. And so you don't have a nice whole number here down in the denominator. So even though the book said you could stop right here, that was because we hadn't introduced this topic yet. In reality now, we cannot stop here. You do not want to stop with a radical in the denominator, even if it doesn't appear to be there at first. It really is once you do the split. So when we apply that here, we're looking at the split is radical x to the 4th on top and radical 3 on the bottom. Now again, I like to take care of, when I see something that needs to be simplified, I try to deal with that right away. And then when I'm rationalizing, it just gives me a little bit smaller numbers or less variables to deal with. So in this case, the square root of x to the 4th, remember with variables we take the exponent on the inside divided by the index. In this case, when we don't see one, it's 2. So 4 divided by 2 is 2, remainder 0, so there's nothing left on the inside. This is just equal to x squared on the top for radical 3. And now we're ready to rationalize the denominator. So we're going to multiply by a radical over radical. What radical? Well, the denominator tells us when it's just a single radical, you'll be able to solve the issue like we did over here by multiplying by that same radical. So when you do radical times the same radical, it puts a perfect square underneath it, and then the square root of that perfect square just gets you back to that number. So that's the point there. So at this point, what we're doing, here's the rationalizing part. At first we were just simplifying it to make it a little bit easier to deal with the multiplying, the rationalizing. We multiply same thing, top and bottom. So that it equals 1, what you're multiplying by. Then what we've got here is x squared times radical 3 on the top. You don't combine, you don't move this back inside the radical. It's outside, it stays outside. Inside the radical stays inside, unless there's reason to simplify what's inside. But radical 3 can't go anywhere. But radical 3 times radical 3 becomes radical 3 times 3, or 9, which we can then simplify to just plain old 3. You'll get to the point where you can just do this and realize you just can jump to 3, okay? Just showing you where we got that. In fact, one additional step might be to show that this was really radical 3 times 3 under the radical 3 times 3. In other words, smushing those two together. Now, tempting, possibly, to see, oh, there's a 3 on top, 3 on the bottom. These are not both 3s. There's a nice 3 on the bottom here. That's what we created it to be by rationalizing. But up top, this is really not a value of 3. This is really the square root of 3, which is 1.71, blah, 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 blah. It goes on forever. So don't be tempted to cancel. Tempting to cancel, but don't. They are not equal. Radical 3 is not equal to 3. You cannot cancel those. You can only cancel exactly matching factors, and these do not match. Okay? So that's really the finished version, x squared times radical 3 over plain old 3. Take a moment to copy what you've seen here. Note any questions, bring those to class. Might want to talk it out loud, either to someone else or to yourself. Maybe go try some of the book problems. But this next one is one for you to try on your own. Number 16, you might want to take a moment to start by asking yourself what's different about it. Then pause the video, see how you do, come back, check your answer. Okay, so the answer to 16 should end up to be Underneath the radical in the numerator is 6x, the whole thing over just plain x. And I'm happy to help explain that one in class. That one has that idea where when you're multiplying the top and the bottom by the denominator that needs to be rationalized, in this case radical x, you split this, then you've got a radical x on the bottom, radical 6 on the top, and then you're multiplying the top by radical 6 by radical x, you've got a radical times a radical. You can mush those together. So that's where that 6 and x come together under the radical. And of course, the design was to get rid of the radical on the bottom, so that's why you just end up with x.